All right, a large rock is falling from the top of a very tall building. The position of the rock is given by the function s of t is 16t squared, where t is given in seconds and s of t in feet. The question is, what is the instantaneous velocity at 4 seconds? So first off, velocity. Velocity we know is the change in position over the change in time, right? So some position at some time 2 minus some position at some time 1 over the change in time. That's how we get velocity. Now, in order to find the instantaneous velocity, we will look at this average velocity and we will make the gap of time decrease to 0. So what we're going to say here is we have our first time, which is 4 seconds. And the position at that time is going to be given as s of 4. Then we have some other time close to 4 seconds. Let's say, how close? We'll say h close. So we'll say 4 plus h. And then its position is going to be at s of 4 plus h. Now, in order to get our average velocity, we will write s of 4 plus h minus s of 4 over change in time, so that is 4 plus h minus 4. Now, in order to get the instantaneous velocity, we will take that h, that space between those intervals, and we will have it become close to 0. Note here that our function s is 16t squared. So what we're going to do is plug that in. So this becomes the limit as h approaches 0 of, first one is s of 4 plus h, so that's 16 times 4 plus h squared minus 16 times 4 squared over our 4 plus h minus 4. Now, to make this simpler algebraically, I'm going to factor out the 16. So that gives me 16. And then I have here 4 plus h squared minus 4 squared. Ignore my handwriting here. All over, and the 4's will cancel, so h. Now, expanding that algebraically, we get the limit as h approaches 0 of 16 times, we have 16 plus 8h plus h squared minus 16 over h. These 16's cancel, leaving me with the limit as h approaches 0 of 16 times 8h plus h squared over h. Then, if I go ahead and factor out the h, I'm left with the limit as h approaches 0 of 16h times 8 plus h over h. The h's cancel, and then I'm left with the limit as h approaches 0 of 16 times 8 plus h. And then at this point, I can direct substitute 0. So I get 16 times 8 plus 0. 16 times 8 is 10 times 8, which is 80, and 6 times 8, which is 48. So that is 128, and our units are feet per second. That's pretty much it.